On November 7, 1867, Maria Sklodowska was born in Warsaw, Poland. Being the youngest of 5 children, she was determined to be the very best from the beginning. This determination would change history forever. Marie Curie and the chemistry of the Imponderable. With the help of some physics lessons from her father, she excelled to the top of her class. Although her public education was over at age 15, Maria was determined to receive a full education. After joining the floating university and undercover academy for Polish women, Maria realized that only a true university could help her reach the top. What did she have in mind? The prestigious Sorbonne in Paris, France. In the autumn of 1891, Maria moved to Paris to study math and physics at the Sorbonne. She changed her name to Marie, the French translation. She placed first in her exam of physical sciences in 1893, unusual for a woman. Not even this discouraged her. I was taught that the way of progress is neither swift nor easy. The Society for the Encouragement of National Industry hired her to begin her first research project. She kept working to get her second degree and earned it in 1894. The same year, Marie met Pierre Curie. He was involved in similar studies and could provide her access to a laboratory for her project. They married in July 1895. Despite being busier than ever, Marie passed an exam to teach to other women and completed her hired work. But now a new obstacle awaited Marie, her doctoral thesis. In November of 1895 came an exciting discovery made by German scientist Wilhelm Röntgen. He had come upon an entirely new type of ray, one that could pass through wood and flesh, and cast an image upon a phosphorescent screen. Röntgen called these mysterious rays X-rays, as in the mathematical unknown quantity. Then French physicist Henri Becquerel discovered that uranium ore emitted an even different ray, but they seemed bizarre and unmeasurable, so Becquerel's rays were hopelessly ignored. But to Marie, they seemed the perfect topic for her doctorate research. Pierre arranged for her to work in an old storage shed. Despite the lack of equipment, Marie turned it into a working laboratory. Marie used Pierre's electrometer to detect small changes in electricity produced by Becquerel's rays. After searching the entire table of elements, Marie found that thorium was the only other element at the time to produce such rays. In a key breakthrough, Marie realized that radioactivity, as she called it, was a property of the atom, something going on inside it similar to a little universe. For centuries, the atom had been thought of as the smallest unit of matter, an indivisible shape. Marie once referred to radioactivity as the chemistry of the imponderable. Then, when sampling different minerals, Marie found that pitchblende, a mined mix of minerals containing uranium, was 4 to 5 times more radioactive than pure uranium ore. How could this be? Marie described to Pierre how she believed that somewhere in the pitchblende a new element was hiding. So she began the tortuous task of boiling down tons of pitchblende, hours of backbreaking work stirring huge vats. Pierre insisted that it was a man's work, but Marie remained strong. Pierre dropped his work on crystals to join in Marie's quest. After 2 years of work, they thought they had done it, but after calling in a spectroscopy specialist to test it, they found out that it was not pure. Not yet. Marie was intent on finding that element. She had never given up, not when she was one of only 2 women in her class, not when she had the unwavering goal of being first with all odds saying otherwise. So with more isolation, she finally got what she had been working her hardest for. On July 13, 1898, Marie named this new element polonium to honor her country. Later that year, Marie came upon an element 900 times as radioactive as pure uranium. On December 20, 1898, she announced the discovery of radium, from Latin ray, to describe how intensely it gave off these new rays. She calculated the atomic weight of her child, as she called radium. By the age of 31, Marie Curie had isolated 2 new elements, discovered a new atomic property, radioactivity, and changed the way the world thought about the atom, not to mention completely shattering the barrier for women scientists in a mainly male-dominated field. Her next step was to purify radium even more, and she wouldn't stop until it was done. Then in the year 1903, the Curies were awarded a Nobel Prize in Physics, jointly with Henri Becquerel. The award was in recognition of the extraordinary services they have rendered by their joint researches on the radiation phenomena discovered by Professor Henry Becquerel. Finally, in 1903, Marie earned her doctorate in science from the Sorbonne. Not only was she the first at the Sorbonne, but the first in all of France. Radium had been getting much attention from the public. Hair tonics, toothpaste, lipsticks, clothes, and even cocktails were dosed with small amounts of radium, supposedly a miracle cure. In 1905, the Curies took a moment away from their work to give the speech for their Nobel Prize. Marie sat in the audience, as was expected of women. In his speech, Pierre urged that radium should be used to do more good than harm. At this time, both Curies were happy, enjoying their life with their two small girls, Eve and Irene. But Pierre was crushed under a horse-drawn wagon on April 19, 1906. Marie only let this intensify her work. Marie took his place as lecturer at the Sorbonne. She was the first female lecturer there, and her students admired her. She worked to isolate radium even more and earned yet another Nobel in 1911. She was the first woman to earn 2 Nobel Prizes, and is the only woman to have won 2 so far. By then, Marie's health was degrading, but she was determined to do something to help World War I, starting in 1914. She wanted to contribute in any way she could, even offering to melt down her own gold Nobel Prize medals, though it was refused. Then she was assigned by the French president to transport all radium in France to Bordeaux, for he feared that if Paris was captured, Germans would use the radium against them. But she was determined to do more, and once she heard that there were no X-rays being used in the field, she sprang into action. She got her driver's license, obtained as much X-ray and automotive equipment as she could find, and assembled an army of cars installed with X-ray units. She was helped only by her equally determined daughter Irene, who was now 17. They were unstoppable, and their cars were called fondly Little Curies. Marie trained nurses and officers to use the equipment while using her own single gram of radium to treat patients with radioactive gas. More than 1 million X-ray procedures were done before the war's end, and after the war, doctors had a new way of performing surgery. They would take an X-ray to find the precise location of shrapnel before operating. After the war's end in 1918, 4 years later, Marie directed the main focus of her work to running the Radium Institute. She wanted to help people with radium, and her institute made it possible with 40 researchers constantly learning. Marie made a trip to the US in 1921 when President Harding presented her with a gram of radium. She lived to see her daughter Irene and her husband create artificial radioactivity, then died on July 4, 1934. Irene and Frederick urged that radium should be used for peaceful purposes, but World War II had different plans, and everyone's worst fears came true. In August 1945, the U.S. dropped atomic bombs on 2 Japanese cities, Hiroshima, then Nagasaki. Americans had built off the Institute's knowledge to create a bomb that showed the fully harnessed power of radium. Over 100,000 people died, instantly vaporized, while others suffered the ongoing effects of leukemia and cancer, and birth defects for generations afterward. Since 1945, nuclear weaponry has not been used, but Marie's discoveries live on in other ways. Radiation is used to diagnose and treat a variety of diseases.
Certainly, medicine would continue without using radiation, but we would have a lot of big limitations.
The food industry uses radiation to kill harmful organisms, and film companies too, to remove dust from film and lenses. Nuclear energy makes up about 12.3% of the world's electricity production. It's cleaner than fossil fuels, but produces harmful nuclear waste. But perhaps the most important contribution to today was how Marie's ideas led to the rebirth of the atom. Right up until her groundbreaking theories, the atom was thought indivisible, not able to change or break apart. But Marie argued that and changed how the whole world thought about not only the atom, but women in science. She opened up a whole new field of physics and discovered 2 new elements. It is impossible to imagine what today would be like without the crucial discoveries made by Marie Curie.